Hi and welcome on this online video. The topic of this webinar is Allinea DDT and the accelerators, and more particularly how to debug Intel Xeon Phi applications. The agenda for this presentation is first to do a short introduction to understand what are the critical aspects when it comes to development on Intel Xeon Phi accelerators, and after this we will see how we can debug very efficiently applications that are meant to run on this brand new architecture. We will show a small demonstration and then we will do a conclusion. As it has been stated by IDC for a couple of years now, and it has been stated once again in August 2012, the applications that are being used on the HPC market today do not use the full size of the machines that are being made available for them. There are multiple issues. The first issue is the number of CPUs that are accessible. So this number of cores is increasing very quickly. And it is also about the hybrid environments using, for instance, GPUs or, more recently, Intel Xeon Phi. Those applications will need a major rework, and they will need to be redesigned and rewritten to take advantage of those new architectures. And as Professor Stephen Jarvis from Warwick University says, this software change will be much more disruptive, as opposed to the one we had 20 years ago with MPI. Allinea is a company that has been created in 2002 to answer this kind of issues. We make parallel programming accessible to the widest range of scientists and programmers. To do so, we developed development tools that can help to reach the highest level of performance and scalability. In particular, we have designed Allinea DDT, which helps to fix the softwares at scale very quickly. Allinea DDT is a graphical debugger that has been designed for C, C++, Fortran, UPC and CUDA codes, and that can work with all the new accelerated environments like GPUs and more recently Intel Xeon Phi. The purpose of Allinea DDT is to slash the time to debug. Thus, we can very easily reproduce and trigger the errors that you face, understand where those errors come from, and help you to fix them very quickly. Allinea DDT has been developed to be completely scalable. Allinea has been working within lots of partnerships and lots of collaborations with Oak Ridge, with the CEA and much more, and we have done multiple things to make our tool very efficient at scale. First, we have worked on the architecture to make it scalable and to make it fast. But we quickly realized that speed was one issue, but was not the most important issue. The biggest issue we faced was to sort and display the information at scale. So we needed to integrate some aggregation and development and data consolidations mechanisms within our tool in order to present the debugging information very easily to the developer. This aspect that has been done 3 or 4 years ago in regards to CPU is critical today when it comes to Intel Xeon Phi. Indeed, those architectures are massively parallel, and the number of MPI processes or the number of threads that can start on these accelerators is huge. This is the reason why having a tool that is capable of handling this level of parallelism is critical. Allinea is leading the way to innovation. We were the first company to support CUDA. We are the first company to support CUDA 5, and we were one of the first companies to support Intel Xeon Phi coprocessors. Once again, this is made possible by the extensive partnerships and collaborations we have made. This is very important as the Intel Xeon Phi is very new. There are lots and lots of new releases that will be coming from Intel, and being able to work with a company that has tight partnerships with Intel and that can very quickly integrate those changes within the product is critical. Without further ado, I suggest that we move to the demonstration. But before doing so, we need to have a look at what the Intel Xeon Phi can do. The Intel Xeon Phi is an accelerator that can be plugged within a server and that offers multiple possibilities and execution models. You can use an Intel Xeon Phi as an accelerator, as a supplement, as a SMP server, which means that you can run MPI processes, threads, or hybrid applications on this accelerator, but it also works as an offload to the host. So you can basically run a program on the host and using either shared memory or a transfer-based communication system, you can use the Intel Xeon Phi that is attached to this host as a real accelerators. Those execution models are all supported and we can already debug all those situations today. In the example that I will be demonstrating now, we will have this kind of setup. We will be running a 200 thread application on the Intel Xeon Phi. To do so, we have a front end on which the debugger will be running that has an SSH access to a host called mic1 and to the accelerator called mic1-mic0. Mic1 and mic1-mic0 share a file system in which a directory called Xeon Phi is located. As I stated, we are now running on the front-end node. We have an SSH access to mic1, as you can see, an SSH access to mic1-mic0, which is the accelerator, and obviously an access to the current front-end. This is the shared directory called Xeon Phi. It is visible on both the mic and the host. In order to create an application running on the Intel Xeon Phi with multithreaded, and in this case, we will be doing some cross-compilation on the host. To do the compilation, we need to add the -m mic option, the -f openmp option, and obviously, as we are trying to debug, the -g option. We need to make sure that the correct environment is available. This is why you can see here that we need to source the compiler vars.sh with the Intel 64 argument. Once all this is set up, we can make the application and it will be ready to run on the Intel Xeon Phi. We are now switching to the environment to the Intel Xeon Phi. As we can see, we can set up the different number of threads on which we want the application to run, specifying the OMP num threads environment variable. And as you can see, this code is running and is providing some results immediately. In order to debug this application within Allinea DDT, a few different steps are required. Here we are on the front-end node, which has Allinea DDT installed. This version of Allinea DDT is specific to the front end and is a very different build from the one installed on the Intel Xeon Phi. On the Intel Xeon Phi, as you can see, we have different binaries. We do not have a DDT binary with a GUI, as a GUI cannot run on the accelerator. Instead, we have different binaries that are being used by Allinea DDT on a global basis. If we start DDT on the front end, what we need to do is to make sure that we have enabled the remote launch. When we enable the remote launch, we need to specify the location of the Intel Xeon Phi, as well as the path to the DDT debugger binary file. A small button called Test Remote Launch is available to try and to make sure that Allinea DDT can successfully access the remote executables. Once everything is working fine, you are ready to start your application remotely. Just click on Run and Debug a program as usual, choose the application you want to debug, specify the number of threads, and do not forget specify the environment variables in which you will add all the dynamic libraries that will be necessary for your application. As you can see, the program is running. This is DDT as usual, working on MPI processes, threads, as you wish. If you play the application, you will see that a breakpoint is reached here, and you can see that the 200 threads are visible and can be debugged. All the tools that are available in Allinea DDT, such as the parallel stack view or the variables, are available, which means that you can debug your application just as easily as if it was an MPI or a standard application running on a cluster. As you can see, we can change the threads that we want to watch. So here we are looking at thread 20, and the variables will adapt and will change, and you will be able to look at the current context within the debugger. The errors will be reported as well to the GUI should the application crash. As a conclusion, you can see that Allinea is a leading company in the HPC software tools market. Our wide range of collaborations, partnerships and customers help us to improve on an everyday basis the quality of our product. Since multiple years now, we know that scalability is an issue for some people. For the biggest labs, it is very important to be able to debug petascale codes. The experience that we have in those environments is very helpful for all our customers. This is made obvious when it comes to Intel Xeon Phi. Indeed, the number of threads or MPI processes that are likely to run on Intel Xeon Phi is very important. As a consequence, being able to use a software debugger that can very easily help to find the bugs and that can very easily manage the very high level of parallelism of those many core architectures is very important. The bugs are becoming more and more complex. The number of threads adds to this complexity. Allinea is pleased to follow the technological advances very closely thanks to the partnerships we have with Intel, with Oak Ridge, the CEA and many others. Thanks to those people, Allinea was the first company to support CUDA, was the first company to support CUDA 5, and tomorrow we want Allinea to be the first company to support the next releases of Intel in regards to Intel Xeon Phi. Should you have any question in regards to pricing or in regards to Allinea DDT and Intel Xeon Phi, for instance about offload or about running MPI codes on Intel Xeon Phi, please do not hesitate to contact us. We would be very pleased to answer all your questions, and our support team would be very happy to give you a trial license of Allinea DDT to run on your environment. Thanks for watching this video and have a very happy debugging.